One thing I like to tell my students when they see multiplication, addition, or subtraction is to apply the operation. That is one of the techniques we use to verify trigonometric identities. However, one thing we also want to look at is whenever we see a trigonometric function squared, such as sine squared, we need to think about our Pythagorean identities. Is there a way that we can simplify this? And one thing we know about sine squared is it's a part of this identity. Cosine squared of theta plus sine squared of theta is equal to 1. Now, if I was to subtract a sine squared of theta to the both sides, I would get cosine squared of theta equals a 1 minus sine squared. That is very important because rather than trying to distribute and somehow get to a sine of theta, cosine of theta, which I'm sure there's a way you can do it because it's not mathematically wrong, the best way in this problem is to actually look into simplifying this first. 1 minus sine squared of theta is now, or can be rewritten as a cosine squared of theta. Now again, we have the squared here, and we need to somehow get rid of that to be able to get a sine of theta times cosine of theta. So the one thing that comes into my brain is I have an extra cosine here. I needed this cosine to divide out. I don't have anything in the denominator here. But one thing that I recognize is that whenever I have a tangent of theta or the cotangent of theta and I need something in the denominator, think about using your quotient identities. Here I have tangent of theta. Quotient identity tells me it's sine of theta over cosine of theta. Now, it's also important to recognize that cosine squared of theta is simply just cosine of theta times cosine of theta. So even though we don't need to do this, I'm going to write it out so you can see how everything's dividing out. Now you can see I have a cosine of theta in the denominator, a cosine of theta in the numerator, and guess what, ladies and gentlemen? I'm just going to be left with a sine of theta times a cosine of theta.